Okay, we have been discussing about the what are all the factors that are to be considered while designing the lightning scheme. Okay, so we have seen the illumination level. Okay, what should be the illumination level in the last class? So we will see the another remaining factors that are to be considered while designing the lightning schemes. Okay, let us start with uniformity of illumination. Okay, so uniformity of illumination. So the human eye actually it automatically adjusts to the brightness, okay, within the field of vision. Okay, so whenever it is, if you enter into a darker room from an open space, okay, during the daytime, okay, suddenly your eyes will get blurred. I don't know how many of you have experienced that. I have experienced it. I have experienced it many a times. Okay, so whenever I enter into a darker room from the open area during the daytime, suddenly I can't see anything. Okay, and after a few seconds, what happens is my eye will adjust to that darker room, and I will be able to see things. Okay, even during night time also, if suddenly power is gone, okay, the room becomes darker. Okay, immediately we can't see anything. After few seconds, okay, our eye will be adapted to that darker room, and we will be able to lightly, of course we can't identify the color of the objects, but we can see lightly. So I can explain it by this image. You can see I'm showing here eye. So under bright light, okay. So I will be having iris, okay, and this is the iris of the eye, okay. It will be having radical muscles and circular muscles. So you can see circular circles here. They are the circular muscles. You can see straight lines here on these circles. They are the radical muscles. So during the daytime, okay, when everything is bright surrounding us, around us, okay, the pupil will contract. Okay, so the pupil of the eye, okay, will contract during the daytime. Okay, the radical muscles will relax, whereas circular muscles will be contracted. Okay, the circular muscles within the iris will contract during the bright light, and radical muscles will relax. Whereas if the light is dim, okay, if the light is dim, what happens is the circular muscles will relax, okay, and the radical muscles will contract. See these lines, okay, these straight lines which you were able to see clearly in this diagram. In the next diagram you can't see them clearly. Their length has reduced, means they have contracted. So the radical lines will contract and the circular muscles will relax. Okay, and you can see the expanded pupil of your eye. Okay, so under during means surrounding of when our surrounding is dark, okay, so what happens is pupil will expand of the eye, and when the surrounding is bright, okay, the pupil will contract. Okay, so it happens automatically. Okay, so human body is an automatic machine. We can say, we can compare our body with an automatic machine. Okay, so if it is cold outside, automatically our body will try to maintain the temperature required. Okay, if it is darker, if it is hot outside, automatically we will start sweating in order to maintain the body temperature. Okay, so it's an automatic machine. So based on the requirement, it will be based on the atmospheric conditions. Okay, so the body itself will try to do some or the in some or the other way, it will try to maintain the body temperature. Similarly our eyes also, Okay, as the brightness, as the surrounding light varies, if the light goes dim or if the light is enough light is there to look at the object surrounding us, when enough light is there, pupil will contract. If when enough light is not there around us, the pupil will expand. Okay, it happens automatically without our notice. Okay, so but it causes, if it is darker outside, what will happen? The eye has to adjust more frequently, and thus fatigue will be caused to the eye. Okay, so and we can't see the surrounding images clearly. Okay, so it is observed that the visual performance is best if the range of brightness is within the field of vision is not greater than 3:1. Okay, if the brightness with respect to the vision is not exceeding 3:1 ratio, if the ratio between the brightness and the vision is not exceeding 3:1 ratio, then enough that range is best for our eye. Okay, this can be achieved by employing the general lighting in addition to the localized lighting. So what is this general lighting? What is this localized lighting? I will explain. Okay, so in order to have a good vision, what you can understand from this slide is that in order to have a good vision, along with the general lighting, we need a localized lighting. Okay, so you can see here in this, you can see poor lighting, you can see a better lighting. Okay, so some people are working here, maybe. Okay, I can't even see clearly these people. So in this is the darker roll number 37. ఓకే, క్లాస్ వినట్లే, రోల్ నెంబర్ 37 క్లాస్ వినట్లా, అంతే కదా. సో ఓకే, సో వెన్ లైట్ ఈస్ పూర్, okay, so we can't see our surroundings clearly, but at better lighting we can work properly. Okay, so if you see here, two people are studying here on a table, on a work plane. They are studying, this table is the work plane, and you can see two lamps here. This is one lamp, this is another lamp, okay, which is fixed to the ceiling. Okay, so here you can see lamps are fixed to the ceiling. So whatever brightness, whatever luminous flux is available on the work plane, using that is helping them to read, okay, do their work. Okay, whatever work they are doing, either they are reading or writing, whatever they are doing. Okay, so the lighting that is coming from the ceiling is known as generalized lighting. Okay, so general lighting provides fairly uniform lighting. Okay, so an example is what? Ceiling fixture that light up large areas. Okay, here you can see the ceiling. So this is our general lighting. Now localized lighting along with the general lighting. Okay, general lighting, just now I have told you this, there are lamps fixed at the ceiling here. Okay, along with that, along with the general lighting, you have a table lamp here. Okay, so table lamp is also there. So already the room was illuminated by the ceiling lighting. Along with that, this table lamp is also providing enough lighting to these people to help them to do their work properly. Okay, so this is the addition of localized lighting along with the general lighting. So local lighting is whatever, wherever we are doing the work, if I fix the lamp at that particular place, that is our localized lighting. Ceiling, general lighting is fixing lights on the ceiling in order to distribute the light uniformly throughout the room. Okay, so localized and general lighting uses overhead fixtures in addition to the ceiling fixtures. Okay, overhead, above their head, a table lamp has been fixed to increase the lighting level of the particular task. Okay, so I have included few more images here. So these are the ceiling lights. Are you able to see? In my mobile it is not clearly visible. I will try to expand the screen. Okay, so I hope you are able to see now. I don't know whether you are able to see or not. Uh, okay, so you can see ceiling lighting. People are doing their work with the help of ceiling lighting. Okay, so this is the general lighting. Okay, Next, you can see on the table, lamps are fixed. Okay, here you can't see the lamp, of course. Here on the table, above the table, wherever they are working, lamps are fixed. This is the localized lighting. Okay, so in the next image, you can see the table lamps are there, localized lighting is there, along with the ceiling lighting. Okay, localized lighting along with the ceiling lighting. Okay, so it gives the better, it is the best option. Okay, if you want to do our work in an effective way, okay, without causing strain to our eyes, if we want to do our work, then it is the best way to use both generalized lighting as well as localized lighting. Okay, so if you want to use only localized lighting, then you can means if you don't want to disturb other people in the same room, if they are sleeping, okay, if they don't want the light, then it is better to use only localized lighting, which we used to do when I was a kid. So in my house, I think once I had told you in the class. Okay, so my father and I myself used to sit um, surrounding the table, and there used to be a lamp there, table lamp, and my father used to do my homework in when I was in first standard, first class. Okay, so he used to do my homework, I will be watching him while he was doing my homework. So it was while my other members of my family were sleeping in the same room. Okay, they were sleeping in the same room. We were reading without them, and because all the general lighting was turned off, they didn't have any sort of disturbance because of the light that we were using. Okay, so these are the examples of localized lighting. Okay, so actually, when we are using localized lighting, it is observed that based on the study, people what they have observed is it causes psychological feeling of loneliness, gloom, and unfriendliness. Okay, so if we are using it for prolonged time. Okay, if I'm using localized only localized lighting for prolonged period of time, then it will cause psychological feeling of loneliness, gloom, and unfriendliness. Okay, that's why in modern trends we are using both localized lighting plus general lighting. Okay, generally, generalized lighting is used for work surfaces, especially in the factories, offices, drawing offices, shops, etc. Okay, so especially in shops, drawing offices, and factories, only generalized lighting is used. Okay, no need of localized lighting. Okay, so it depends based on our requirement. We will use. Okay, both or only one. Okay, so see, you can see this image. In this image, a person is doing his work. Generalized lighting is there. It is around 3500 k to 4000 k. Okay, and ambient of and this lamp is of 2500 k to 3000 k. Okay, so this is the localized lamp, this is the general lamp. Just for example, no need of these values and all are not required. Okay, so wattage and all are depending on our requirement, we will buy it for our houses. Okay, so ratings of the means what based on the illumination that you require, the ratings of the lamps will vary. So ratings are not important. Okay, so some people even prefer the natural light to come into the room in which they are working along with the generalized and local lighting. Okay, so it depends. Okay, so this slide is actually not of much importance, but I have inserted it to give you some information. Okay, so this is about the uniformity of the illumination. Okay, if I want the illumination to be uniform throughout the room along with the general lighting, better to use the localized lighting. Okay, next, color of the light. Okay, so we based on the color of the light, the body color will entirely vary. Okay, if the color of the light is varying, the object color will also vary. So you can see in this diagram, not diagram, in this image, you can see here, I have the color of the lamp is yellow. Of course, it is a sodium vapor lamp. You can see by looking at this image itself. See the surrounding. each and every object is somewhat yellowish in color. Okay, whereas the color of the lamp is white in the other image, and you can clearly, because of this white color, you can even identify the color of these trees. Okay, so the color of the objects on which the light is falling is varying depending on the color of the light. Okay, so depending on the color of the light, the body color will also vary. Okay, so why two images are there? No, only one. Okay, so in general, the composition of light should be such that color appears natural. Okay, so whatever artificial lamps that we are using, so we must make sure that that lamp gives out the whatever light comes out that of that lamp, that light should be, the luminous flux should make the objects or the body to appear with its natural color. Okay, so usually it is observed that most of the in this modern era, okay, so whatever lamps that we are using, they are the images almost look similar to what they look during the daylight. So you can see here during in this room, natural light is coming into this room. Similarly, artificial lighting is there in this room. They all are looking similar. Isn't it? Both the images are looking similar. Okay, the color of this means you can see the true color of this table or this seating chairs. Okay, you can see the true color of each and everything in this room even during the due to artificial light. Almost similar. We can't say 100%. You can't equate it to the natural light. Okay, but it is almost similar. Much difference is not there. Okay, so daylight fluorescent tubes nowadays make it possible to illuminate economically even large spaces with artificial daylight, giving good color rendering and at sufficiently high level. Okay, and in some places such as when you are moving on a road during the daytime in a vehicle, okay, so the color of the objects surrounding you, color of the body, things which are surrounding you are not of much importance. Okay, in such places we can use the lamps which have poor color rendering capacity, such as sodium vapor lamp. Okay, sodium vapor lamp has poor color rendering capacity. So you can see in this image we can't even clearly identify what is the color of the building or tree or these cars which are surrounding here around this road. Okay, so for certain applications such as street lighting, okay, so street lighting, the color of the light is not of much importance. Okay, because we don't want to distinguish between the color. Okay, so we don't want to distinguish any object by the color. Okay, therefore we can use any lamp, okay, which can give out light. That's all. That is more than enough. Okay, so even the lamps which cause color distortion can be used for the street lights. Okay, so this is about the color of the light. So color of the light, it means if we are using the lamps on the streets, okay, for the streets, then color of the light is not important. But when we are using for offices or indoor purpose in our houses or somewhere within the building, then color of the light is also very important. Okay, next is shadows. Okay, so when light falls on an object, definitely you can see the shadows. Okay, but it is observed that long and hard shadows causes fatigue to the eyes. Okay, if the shadows are long and hard, they causes fatigue to the eyes, so the shadow should be shortened. Okay, so and it is also observed that if shadows are not there, means when the in the complete absence of shadows, okay, we can't clearly identify the borders of the object. Okay, so we can't call it as an ideal condition. Okay, absence of shadows is not an ideal condition. Presence of shadows, if long and hard shadows are there, it causes fatigue to the eye. Even if shadows are not there, it is not an ideal condition, because the borders cannot be clearly identified for an object or an image if shadows are not there. Okay, so certain amount of shadows are desirable in artificial lighting. It will help to give shape of the solid objects and make them easily recognizable. Okay, so shadows are important, but they should not be long and hard. Okay, They should not be long and hard, but they will help us to identify the shape of the object. You can identify the borders of the object, and you can easily recognize. Okay, you can easily recognize the object. Okay, just for example, you can see here. Okay, so this is a ball on which light is falling. Okay, so because of this shadow, you are able to clearly identify what is the shape of this ball. Okay, just for example, I have inserted that. Okay, so objects illuminated by shadowless light appear flat and uninteresting. Okay, based on the analysis, people what they have observed is that whatever objects are means if the object is shadowless, then it will appear flat and uninteresting. Contours are lost, means their boundaries are lost, and it is difficult for the eye to form a correct judgment of the shape of the object. Okay, so based on the analysis, what the engineers have found that we can't identify the proper shape of an object if shadows are not there. Okay, so but in some cases, okay, shadows should be avoided. Zero shadows should not be there. They should not completely shadowless, such as drawing offices. Okay, so people who do the drawing work means especially for drawing purpose only. Some people will be um, working. Okay, so when I was a kid, so there was a person from Ongole who was working in front of my house. His office was in front of my house. I forgot the name of that office. Okay, his purpose was only to draw. That's all. He will go to the office only to draw. Okay, so the people who do only drawing work in the offices, for them the illumination should be such that it won't cause any shadows on the surface or on the work plane on which they are doing the work. Similarly, in the operation theaters, okay, even in the operation theaters, shadowless illumination should be there, okay, so that they can do their work effectively, okay, and the shadows, the hard and long shadows can be avoided. Okay, it can be avoided if I am using large number of small luminaries mounted at height, not less than 2.5 meters from the surface. Okay, from the surface above 2.5 meters, if I am able to fix the luminaries, means lamps. Okay, large number of lamps. Okay, then shadowless illumination can be obtained. So you can see this is an office in which n number of many luminaries are there. Okay, so shadowless, you can see the surface. In the surface, no, you can't see any shadow here in this room. Okay, and okay, we can even avoid these long and hard shadows by using wide surface sources of light using globes over filament lamps. Okay, so if I'm using globes over filament lamps, I hope, let me check, do I have any image of globe type? Yeah. So if I am having globes, okay, you can see inside there is a lamp, and it is surrounded by a diffused glass, just for example here. Okay, if it is surrounded by a diffused glass, okay, then shadows can be avoided. Okay. And if I am using indirect lighting system, I have already told you. Okay, so in the case of if I am using indirect lighting system, then shadows can be avoided. So if we want to avoid shadows in some places, such as drawing areas and operation theaters, we can use n number of luminaries. So you can even see here there are many luminaries here, lamps here, just above the work plane of these people who are performing some operation here. And if I am using globe type diffusion glass surrounding the lamp, then also shadows can be avoided. If I am using indirect lighting system, then also shadows can be avoided. Okay, so next one is glare. Okay, so I think what is meant by glare. Okay, so glare can be either direct glare or reflected glare. Okay, it may come directly from the light source, or it may be reflected back from the desktop or nickeled machine parts or calendared papers. So if you observe, I don't know how many of you have observed, the calendar papers will be very shiny, okay? So in our houses, so they will reflect light, okay? So even the machines with nickel metallic parts, okay? And the desktops, so which are smoother in surface, they will also reflect light. Okay, so if you stand in front of a direct light source, okay, for example sun, okay, if I am looking directly towards the sun, then I can't see. So when I was a kid, I was told to not look directly at the sun, okay, so it will damage your iris. Okay, I was told that, so I never used to look at the sun in the sky. So while when we were kids, we will be very much enthusiastic to try new things. Okay, so I never tried this thing. So you see, a person is looking towards the sun, and so, she is unable to look at the sun here, isn't it? That's what this image shows. Okay, so whenever we are looking, see during night time, whenever we are traveling, okay, so you can see the glare that is coming, glare due to these lights which are glowing in front of the vehicles. Okay, glare is the one which causes discomfort to the eyes. Okay, so glare is the one which causes discomfort to the eye. I think I have a slide here somewhere I have written. It causes visual interference. Okay, it causes when you are looking at a vehicle, because of the lamps that are glowing, the front lamps which are glowing in front of that vehicle, you can't see the vehicle clearly. Okay, so glare occurs when one part of the visual field is much more brighter than the average brightness to which visual system is adapted. Okay, it causes discomfort and loss in visual performance and visibility. Okay, so it can be a direct glare or indirect glare. So if it is a direct glare, so when I am looking directly towards this vehicle, I am unable, it causes discomfort to my eyes. That is the direct glare. So a person here is working in front, he's sitting in front of his system and he is working here. See, there are some lamps fixed on the ceiling. Okay, so you can see here the light is falling on this screen, and it is reflected towards his eye. So that is the indirect glare. Similarly, you can see lamp light is falling on the surface of this desk or this table. It is reflected by that is also an indirect glare. Okay, so if the light falls on some surface and it reflects back towards our eye, that is the indirect glare. Okay, so I have one more example of indirect glare. So this person, you see, there is a tall building here which is fixed with mirrors. Okay, so a person is looking towards the wall, but because of the glare, okay, he is unable to see the building. Okay, so glare can be either direct glare or indirect glare. Okay, if the lamps are fixed very nearer to our above our head, okay, very lower towards the surface, then directly if the light rays falls into our eye, it causes glare. Even the light ray coming from the window, okay, even the light ray coming from the window can cause glare to our eyes. Okay, so if it is an indirect glare, the light rays will fall on any surface and it will be reflected towards our eye. Okay, even this table lamp, if you see, there is a table lamp here. From there, light ray is falling on the screen, it is going towards the eye. Okay, that is reflected glare. Okay, so I don't know. Okay. Okay, so in order to avoid this glare, usually this lamp should be mounted at such a height that okay, it won't cause any irritation to our eyes or to our vision. Okay, so in order to avoid the glare, generally the lamps are in the industrial lightings. The metal reflectors are used for industrial lighting to avoid the glare. Okay, so you can see here, this is a reflector along with the diffusion glass which is placed in front of it. Okay, this is a metallic reflector in which lamp is there. So if I am using this sort of arrangement, I can avoid the glare to the eyes. Okay, so next, mounting height. Okay, So the mounting height should be will depend on the what type of building in which you want to mount the lamp and what type of lighting scheme that you want to employ in your house. Or it can be house or industry or office or a um, college like this. Okay, so it depends. The mounting height will always depends on type of building and type of the lighting scheme that is to be employed. Okay, so we already know in case of direct lighting, so they are usually fixed at the ceilings. Okay, so in case of direct lighting in a room of large floor area, luminaries should be mounted as close to the ceiling as possible. Okay, which we already know. Okay, so if I'm using direct lighting for a larger floor area, luminaries should be mounted as close to the ceiling as possible. Okay, so if I want to just lower the luminaries, means if I want to fix the direct lighting lamps a bit at a bit lower position, means nearby to the surface, not completely nearby, but instead of fixing to the ceilings, if I want to reduce the height of the lamp with respect to the surface, then it may cause more field vision and increase the glare. Okay, so and without causing any appreciable increase in coefficient of utilization. Okay, so it may increase the glare to our eyes if these direct lamps, if their height is reduced, instead of fixing them at the ceiling, if they are fixed at a height which is a bit closer to the surface, not completely closer, but bit closer. So in general, okay, so the lamp above the workspace, direct lamps, direct lighting system, the direct lighting lamps, okay, should be fixed about 30 to 36 inches above the work plane, and distance between the lamps should be around 30 inches. Minimum distance should be 30 inches. With respect to the floor, the lamp should be fixed around 60 to 65 inches above. Okay, so if I want to fix the lamps uh, outside outside the house, besides to the entrance door, okay, so I must fix almost nearly at the nearer to the top of the door. Okay, okay, that's all. I think first two diagrams are more than enough. The lower two diagrams are not of much importance. They won't give much, we can't get much knowledge about the topic that we are discussing, mounting height of the lamp. Okay, so I will leave it. So see in this image, you can see the direct lamps are there and their ratings are varying. Okay, their ratings are varying here. So one is 100 watts capacity. Okay, if a lamp is of 100 watts capacity, the area it can illuminate is around 30 feet. Okay, so it should be fixed at a height of 10 feet. Okay, so it should be fixed at a height of 10 feet. Okay, so means you can fix the direct lighting scheme lamps above the floor with a hanging. Okay, if the wattage is around 100 watts. If the wattage is increased to 150 watts, okay, so it can illuminate the surface of around 36 feet. It should be fixed at a height of 14 feet. Okay, and if the lamp is of 200 watts, it can illuminate the surface of around 42 feet surface area, and it should be fixed at a height of 16 feet. And if a lamp is of 240 watts, it can illuminate a surface of around 48 feet, and it should be fixed at a height of 18 feet. Okay, it's just to give you some information. Okay, these values are, you need not by heart these values. Just to give you some information, I have included this slide. Okay, so if this is what we have discussed is was with respect to the larger surface area room. If the room is small with a high ceiling, okay, so if we have a room which is of smaller surface area, okay, small room with high ceiling, then definitely the luminaries have to be lowered with using some hangings. Okay, so we need to use filament lamps. Okay, any lamp, okay, whatever lamps that you're using with focusing reflectors mounted on them. Okay, so you can see here in this diagram, so the luminaries are, of course, they are not hanging, but they are fixed to the ceiling, but they are having focusing reflectors. You can see the reflectors here, okay, with a diffusing glass in front of it, okay, in this tag image. Okay, so if the room is a smaller room with high ceiling, if I'm using direct lighting, then I must use focusing reflectors for in order to illuminate the room. Okay, so this is it. Okay, and if I'm using indirect and semi-indirect lighting, so we know that indirect and semi-indirect lighting will be focusing towards, most of the light will be focusing towards the ceiling. So what about the surface? Because ceiling is very high, but okay, but the room is very small. Okay, so for that purpose, luminaries are usually hanged with the help of, they are brought down with the help of hangings. Okay, so here you can see these are the windows. Okay, so and there are double windows here actually, one above another. Okay, so means the ceiling is very high, and you are providing an indirect lighting here. Okay, so this is an these lamps are focusing upwards, that's why they have brought down by using some hanging. Okay, so it is means there is a proper calculation in suspension of these hangings. The calculation is that the suspension tube. Okay, so this tube, where is it? This tube. Okay, this is the suspension. This rod type structure above these lamps is the suspension tube. The suspension tube should be 1/4 to 1/3 of the horizontal spacing between the row of luminaries. Okay, so that care is taken while fixing these luminaries of indirect and indirect, semi-indirect lighting. Okay, so it is not always possible to suspend them as far down as possible, because it is quite generally recognized that there should be minimum clearance of 2.5 meters between the luminaries and the floor. Okay, so whenever we want to suspend the luminaries from the ceiling, then you must make sure that the height of the luminary from the floor should not be less than 2.5 meters. Okay, so if the room has lower ceilings, the illumination in the ceiling is unavoidable, non-uniform. Okay, so for lower ceilings room, the ceiling illumination will be non-uniform, but it is not of much importance. Why? Because its ceiling is not the work plane. Okay, so if for the illumination to be uniform on the ceiling should be at a very ceiling should be high. Okay, so for low ceiling you can't get the uniform illumination, but since the ceiling is not the work plane, it is not of much importance. Okay, next, spacing of the luminaries. Okay, spacing of the luminaries. Okay, ma'am, thank you. Oh, 1 minute. Someone came and I just closed my presentation. Wait for a second. Okay, spacing of the luminaries. Okay, so what should be the distance between the lamps? Okay. 1 minute. So the correct spacing should be there for uniform illumination in a particular room. Okay, so the dark areas should be avoided. There should not be, the luminaries should be placed in such a way that there should not be any dark area. Okay, so if the fittings, the lamps are not equally, if the distance, correct distance is not maintained between the luminaries, then there will be dark areas with on the surface. Okay, so in case of direct and semi-direct luminaries, the ratio of horizontal and spacing between rows to the height of the luminaries above the work plane depends on extent on the candle power distribution curve of the luminaries. It depends on the candle power distribution on the luminaries. What is the candle power of the luminaries? Based on the candle power of the luminaries, if I am using direct and semi-direct luminaries, the spacing between the horizontal and the rows to the height of the luminaries will vary. Okay. So when I am using fluorescent luminaries, so it is good practice to aim at the value of unity of this ratio, which is set up to a limit of 3/4. I think you didn't understand whatever I am telling you. Now we look at this room. This is a room. Okay, we are looking from the top view into the room. Okay, so when we look from the top view into the room, we are able to see these rectangular boxes are the lights in this room. Okay, you can see the length and width of this room. This is the width of the room of 9 meters. This is the length of the room of 6 meters. Okay, so dimensions of the rooms are known to you now. Okay, so here approximately you have 8 lamps within this room. Okay, so while placing these lamps into the room, some calculations are to be maintained. Okay, so you will start with this distance, which is known as distance of this lamp with respect to this wall. Okay, it is the horizontal distance between the luminaries and the wall. Okay, horizontal distance between the luminary lamp and the wall is, it should be around 1.125 meters. Okay, 1.125 meters distance should be maintained. Horizontal distance should be maintained from the wall towards the lamp. Okay, okay. So and the distance between lamp to lamp, that is known as transverse spacing. Okay, that is known as transverse spacing. So here actually we will consider the center of the lamp. Here you see the arrow mark is not ending at the starting of the lamp, it is ending at the center of the lamp. Similarly, from this center of the lamp to this center of the lamp, okay, this distance is known as horizontal midpoints. This distance is known as horizontal midpoints or transverse spacing. It should be around 2.25 meters. Okay, so from this midpoint to this midpoint, it should be 2.25 meters. And okay, from the midpoint of this lamp, from here to this side wall, okay, that is known as vertical distance between the luminary and the wall. So the vertical distance between the luminary and the wall should be around 1.5 meters. Okay, vertical distance should be 1.5 meters. Okay, so from this center to this center, it should be 3 meters. So 1.5 plus 3 meters plus 1.5, it is 6 meters. Okay, similarly, this length should also be 9 meters. So it is 1.125 from here to here, from here to here 2.25, from here to here it is 2.25, from here to here it is 2.25, from here to here it is 1.125. Okay, so from this center to this center, it is known as axial spacing. Okay, so it is the double of the distance between this center to this wall, this center to this wall. The distance should be double. Okay, so these are all the measuring lengths while placing the n number of luminaries in a particular room. Okay. So if I'm using tungsten lamp combined with a focusing reflectors, then the ratio of spacing to the height should be about 0.6. Okay. So if I'm using indirect and semi-indirect luminaries, horizontal spacing between the rows, approximately it should be equal to height of the ceiling above the work plane, and the horizontal spacing should not exceed 1.5 times the height. Okay, so this whatever we have discussed was with respect to the direct illumination. Okay, so in case of fluorescent luminaries, 2 or more luminaries are joined end to end so that they can share a common outlet. Okay, just for example this. So all these luminaries are joined end to end to share a common outlet. Okay. In fact, it is often works out well to use continuous rows of luminaries, especially when the specified illumination is fairly high. So whenever you want more illumination, okay, fairly high illumination, in such case, what you must do is you must use continuous luminaries, means similar to this. Okay. So next, color of the surrounding walls. Okay, so color of the surrounding walls will definitely um, affect the whatever illumination that is coming from the lamp. Okay, that illumination is affected by the color of the surrounding walls. Okay, so what is the what you in general you people might be knowing that in general from our ancestors long back onwards we always prefer white color to the walls. Okay, so why? Because white reflects light. Dark colors absorb the light, but light colors will reflect the light. So you can see this is a both are this room is illuminated as well as this room is also illuminated. But this room looks a bit darker because based depending on the coloring of this wall. Okay, so it has a bit darker color here. Okay, you can see an indirect lamp here in this what is this mirror. Okay, so because the walls are dark, even though it is illuminated, it's not looking much brighter when compared to this room. In this room the walls are painted with white color, therefore it looks more brighter. Okay, so always white color reflects I mean will give out more illumination, even though you provide much more lamps in the room. Okay, but if the walls are painted with white color, it will reflect more means it looks more brighter in color. Okay, so this is it about the design, different design aspects. Okay, so if anybody wants me, of course I can't repeat now.